exam for Aerospace Engineering branch. Okay, and this is the weightage of engineering mathematics in this paper. We had 6 1-mark questions and 6 2-mark questions. So total 6 plus 12, 18 marks out of 100. So, that shows the importance of mathematics for GATE exam, especially for aerospace engineering. Okay. So with that background, let's take the first question. This was question number 11 in your question paper. You can check the answer key, etc. accordingly. So the first question is for any real symmetric matrix. So these are important keywords. So in every for GATE exam, in any branch, the most important thing is to read the question properly and then solve it. Many students read it in a hurry and then miss on important details and then make mistakes. Okay. So in this question, they have given you the information. It says for any real symmetric matrix A, the transpose of that matrix is equal to, and you have to select one option out of the 4 options given. Okay, so the definition of symmetric matrix itself is essentially you will have a matrix of this form. Okay, so the diagonal elements could be different, and the necessary condition is non-diagonal elements should be equal to each other when you interchange their rank and column index. Okay, for example, this could be one simple example of a symmetric matrix of order 3 cross 3. Okay, so now they are asking about transpose of this matrix. So you should know, when you take transpose of any matrix, the principal diagonal elements do not change their positions, whereas the non-principal diagonal elements swap their positions. So basically their row and column index is changed. Okay, but since this is a symmetric matrix, even if you swap 4 with 4, in the end you will get the same matrix only. So that's why for symmetric matrices, the transpose is the original matrix itself. Okay, because it's the definition of symmetric matrices, and then once you take the transpose, they have the same elements in the non-diagonal places, so therefore you'll end up with the same matrix. Okay, so this is I would say one of the simpler questions difficulty wise, but you should know certain concepts about matrices. First is about what is a symmetric matrix. So this is one simple example of it. You can take one 2 cross 2 matrix example also, but in general we go with 3 cross 3 for GATE exam. And you should know what is the transpose of a matrix. Okay, so if you knew these two concepts, you would have easily guessed the answer, and from the options you can see the answer is option D. Okay, and one simple example I have just taken in front of you. Okay, so yeah, correct answer is option D. I hope, the last batch who I taught the mathematics course, I think we have discussed even more difficult concepts than this one related to concepts of transpose of a matrix, various types, etc. So they would have gotten this question correct. Okay, because it was not that difficult one, but you should know some matrix concepts. Then only you can easily solve this with less time. Okay. So that was about question number 11. Then let's go to question number 12. So in this question, they have given you 3 equations. These are linear equations, and this is from the topic of, again, linear algebra, but this is called as, the name of the topic is system of equations. Okay, so this one also we had covered in depth when we had taken the normal sessions for the previous batch. Okay, so these type of questions, the standard way is to go, you have to form you have to convert this system in a AX equal to 0 form, which is called as a homogeneous form of system of linear equation. Okay, so where A is your coefficient matrix. Okay, this is your coefficient matrix. So basically, it consists of coefficients of all the variables in your equations. Okay, and then depending on, since this is a homogeneous system of equations, these system of equations are always consistent, and there are only two cases possible. One is unique solution, and another one is infinitely many solutions. Okay, so even if you knew this much, this much idea about homogeneous system of equations, you could have guessed that these two options could not be the solutions. Okay, because there are only two possible solutions for homogeneous system of equations. So either A or B should be the answer. Okay, now we'll solve this in slightly deep manner, but the correct answer is given as B, and we'll see how. Okay. So we'll first write this expression in a this coefficient matrix form, but before that, let me just give you one simple tree diagram so that you can remember this going forward. Okay, so if if your coefficient matrix is a square matrix, then you can take the determinant of it, and if that determinant comes 0, or if it is, some cases it can be a rectangular matrix. So if rank of your matrix, coefficient matrix, is less than the number of unknowns, okay, so where n is number of unknowns, so in those cases you would get infinitely many solutions. Okay, and if it is a square matrix, if the coefficient matrix is a square matrix and the determinant of it is not 0, or in many cases it can be a rectangular matrix also, in that case you need to check the rank of coefficient matrix, and if it is equal to n, then you will have unique solution. Okay, so now this was discussed in our regular classes. So now if you go back to your system of equation, which are three equations and three unknowns are x, y, z. So if you if you form this coefficient matrix for a given system, for a given uh, system of equations, we can write A matrix as, the first equation has 2, 3, 1 x, y, z coefficients, right? So you need to make this as a first row, 2, 3, 1, and these will be your unknowns x, y, z. And since it's a homogeneous system of equation, the RHS, or sometimes we call it as B matrix, all entries will be 0. It's a null matrix. Okay, and then you have this thing. Second equation is x plus y equal to 0, so that will be 1, 1, 0. And the last equation is y plus z equal to 0, so that gives you 0, 1, 1. Okay, so since this is a 3 cross 3 matrix, the easier check is to calculate the determinant of this matrix. Okay, so let's call this matrix as A. Okay, this matrix as A. Then the determinant of this matrix, you should know how to calculate the determinant of a 3 cross 3 matrix. It's a standard procedure. Okay, so it will be 2 into 1 minus 0 minus 3 into 1 minus 0 plus 1 into 1 minus 0. Okay, so all the square brackets are 1, so it is essentially 2 minus 3 plus 1, so that is equal to 0. Okay, so the determinant of this matrix is 0, and if you just this was the tree diagram that you are supposed to remember, so you can just, by looking at it, you can say that this system of equation will have infinitely many solutions. Okay, so that was your option B. So this is how you should approach this type of questions, and multiple times such questions have been asked in the previous year also. Okay, so sometimes they will give you homogeneous system of equations, sometimes they will give you non-homogeneous equation system of equations. So in that case, the RHS will be not a null matrix, it will be a some column matrix, and then there are three cases there, so you should remember that tree diagram. We discussed that. Okay, So it was about question number 12. Again, it was, I would say it was also a easier difficulty level question if you are a serious candidate for GATE. Okay. Now let's move on to question number 13. So it is also again from linear algebra topic. So there are first three questions that we solved. All of them are from linear algebra. Okay, so that is a very important topic to tell you the importance of various subtopics in the mathematics course itself. Okay, so here they have given you, let's say, this matrix A, which is 1, 2, 0, 3, and what they're asking you to find is eigenvalues for this matrix. Okay, so more often than not, one question is asked on these eigenvalues and eigenvectors. Okay, in most of the branches of engineering for GATE exam. So this is also very important topic. Very important topic. I mean, this question is, I would say, still a easier question, but many a times they ask very tricky questions also from this topic. So you should thoroughly prepare these things. Okay, we have covered these topics in details in the previous batch, and in current batch also we are going through those. Okay, so let's leave that aside. Let's try to solve this question. See, the correct answer is C, option C in this case. But you have this matrix A, which is 1, 2, 0, 3, right? So the standard method to find eigenvalues is you need to calculate the determinant of you know uh, this A minus lambda I matrix and equate it to 0. So since it's a 2 cross 2 matrix, it will be a quadratic equation in lambda, and then you'll get two values for lambda. And if it's a 3 cross 3 matrix, it will be a cubic polynomial, and you'll get three values of lambda. Okay, so depending on the nature of lambdas, various inferences can be drawn. But in this question, they are just asking you to find the lambda values. Okay, so if you use the classic definition of uh, you know this procedure to find the eigenvalues, it is pretty straightforward. So you need to find the determinant of this matrix, which is nothing but 1 minus lambda into 3 minus lambda equal to 0. Okay, so lambda values are 1 and lambda equal to 3. So these are two eigenvalues of this matrix, which is option C. Okay, there is another way also to find the eigenvalues of this matrix, where you can use the concepts of trace and determinant. Okay, so we know the trace of a matrix is nothing but summation of eigenvalues. Okay, and trace is nothing but trace of a matrix is sum of its principal diagonal elements. So here the principal diagonal elements are 1 and 3. So therefore, lambda 1 plus lambda 2, which are your unknown eigenvalues, should have their summation equal to 4. And another property of eigenvalues is the determinant of eigenvalues for a matrix give you the product of all the eigenvalues. Okay, so here it's a 2 cross 2 matrix, so you have only two eigenvalues. So therefore, the determinant of matrix A will be your product of eigenvalues. So that is nothing but 3. Okay. So, based on this information also, one could have solved this problem. You can see you need to solve basically these two equations, where lambda 1 plus lambda 2 is 4 and lambda 1 into lambda 2 is 3. Okay. So just by looking at the options, you could have found the answer, where lambda 1 is 1 and second eigenvalue is 3. Okay. So there are two ways to solve this question. One is using the classic definition of eigenvalues, and another one is using the properties of trace and determinant and their corresponding relationships with the eigenvalues. Okay. Both of these approaches are useful in various kinds of problems. In this problem, both were easily solvable. The question was solvable by using both the approaches. But in some problems, you may have to take a call, and accordingly, your problem difficulty will be reduced. Okay. So this was again one of the easier difficulty question from linear algebra topic. I am assuming that most of the students who appeared my last class would have gotten all these three questions within reasonable time. Okay. So now now the flavor is changing. So in question number 14, they are talking about partial differential equation. We use PDE as a acronym for this in various places. Okay, so they have given you on the second order PDE where x and y are independent variables and u is some function of x and y. Okay, so this u is some function of x and y, and then we take partial differentiation with respect to x, and then partial differentiation with respect to y, and then higher order derivatives you can do. So now the question is, they have given you the second order differential equation, and they're asking you what is the nature of this equation, whether it's elliptic, hyperbolic, parabolic, or some mixed type. Okay. So first of all, those who have attended last class, there is no such thing which is like mixed type if it is the PD is of this form. Okay. So the answer could be any one of the first three. So now this also we have discussed. So this is it is a standard method to determine the nature of this kind of equations. So I'll just tell you what is the standard way. So general form of a second order PD that we are dealing with. So here they have given you a specific PD, but let's say in general if you have such a PD and how to find the nature of that PD. So let's say you have uxx represents the second derivative of u with respect to x, which is nothing but if you look at this, uxs is nothing but the second derivative of u with respect to x. Okay, so like that. So then you have some b. So this capital A, capital B are some scalars, constant values. Okay, and let's say you have another constant multiplied with second derivative of u with respect to y, and it is equal to some function of x, y, u, or some first order derivatives. Okay, so that doesn't matter because since it's a second order PD, its nature is dictated by the highest order terms, which are uxx, uxy, and uyy. Okay, so in this case, if if b square minus 4ac is equal to 0, this is called as parabolic form of PD. Okay. If it is less than 0, that is called as elliptic PD. And if it is greater than 0, that is called as hyperbolic PD. So this one also we had discussed in our regular classes. Many examples were also solved. Okay, so here, if you remember this part, which you should, if you have attended my classes, you just had to choose the values of ABC from the given equation. Okay, so in this equation, if you compare the coefficients, A comes out to be B, A comes out to be equal to 1, B comes out to be 4, and C is equal to 2. Okay, and now you just need to find B square minus 4AC for those values. Okay, so B square minus 4AC for given question becomes B is 4, so 4 square minus 4, A is 1 and C is 2. So it is essentially 16 minus 8, which is 8, which is a positive value greater than 0, and therefore given equation is hyperbolic. One second. Hyperbolic. Okay, and I think that was option, if you just check, that is option B, and that is also the correct answer. Okay, so I would say this is also, if I mean the underlying assumption is you had attended my classes, and if you had properly revised these concepts throughout the course of your preparation, this is also not a very difficult question, to be honest with you. But if you had not followed thoroughly repetition or the revision, etc., then these easy marks also some students would have lost. So you should not do such mistakes. Anyway, so this was about one question from differential equations topic, particularly partial differential equations. Okay. So let's go to the next question, which is question number 15. And this is a question where they have given you a function, and the definition of function is given as a plus x when x is less than 2, and it is 1 plus x square when x is greater than 2. Okay, so essentially, and this value of a is a constant basically, because all the options are constant values. And what they're asking is if a function f of x is continuous at x equal to 2. Okay, so you need to find the value of a. Okay, so this is again a question from limits, continuity, and differentiability topic from our calculus. Okay, again, if you had studied calculus properly from my previous classes, this was also not that difficult of a question. Okay, and how should you solve this question? That's the next part. But here, you need to pay attention to certain keywords. Okay, so they're asking the continuity condition at the point x equal to 2. And you can see from the definition, at x equal to 2, you have the change in the definition of the function. Okay, because when less than 2, it is a linear function of x. But when x value is becoming greater than or equal to 2, it is a quadratic function of x. Okay, so we need to find a such that it becomes a continuous function. That's the main trick. Okay. So the correct answer for this question is C, and we'll just see how do you get that. Okay, but I'll just give you one general solution so that it is applicable for all the functions that you may come across. Okay, so for a function, let's say f of x to be continuous at some point x equal to x naught, it needs to satisfy certain conditions, and they are given as uh, uh, let's say left hand limit. So left hand limit of this, we also call this as LHL, acronym is used. Left hand limit of f of x at x equal to x naught should be equal to right hand limit of f of x at x equal to x naught. Actually, you should not say x equal to x naught, but it is like approaching x naught. Okay, so that underlying distinction is there, but just for the sake of simplicity in the writing, and both the limits should be equal to f of x naught. So actual value of that function at the given point should be equal to LHL and RHL. Okay. So what does LHL and RHL mean? In a brief sense, let's say this is your x equal to x naught point, and some function graph will be there, right? This will be your f of x. Okay, so this is a general function. So LHL means, let's say if you draw a vertical line here at x naught, LHL means you're approaching this function at x equal to x naught from left hand side. Okay, and RHL means you're approaching the f of x at x equal to x naught from right hand side. Okay? So you need to use those definitions of functions when you solve this problem. Okay, so here in this problem, they have given the x naught as, in this question, x naught is nothing but 2, because they're asking you to find the continuity at point x equal to 2, and your f of x is of the form a plus x and 1 plus x square for x less than 2 and x greater than or equal to 2, right? So left hand limit for this function, which is also called as limit x tending to 2 minus of f of x. So 2 minus, this minus sign is superscript. Okay, so it does not mean that you take minus 2. That is wrong. Okay, that means you are approaching 2 value from left hand side. Okay, and as per the definition, this should be function a plus x, right? Because when the values are slightly less than 2, the valued form of function is a plus x for given f of x. Okay, so here you have to put x equal to 2, and you get left hand limit as a plus 2. Similarly, RHL is your limit of x approached from right hand side, so that is also denoted as 2 plus f of x. Okay, and in this case, when you are approaching x equal to 2 from right hand side of the real line. The nature of the function is 1 plus x square. Okay, so here you have to put x equal to 2. So that will be 1 plus 4 equal to 5. Right. And actual value of this function at x naught, which is nothing but f of 2, is also 1 plus 4, right? Because at x equal to 2, it is 1 plus x square again. So that is also fine. Okay. So now, if you had come up with this formulation, it is pretty easy to find the value of a, right? So for f of x to be continuous at x equal to 2, because x naught is 2 here, this LHL, which is a plus 2, has to be equal to RHL, which is 5, which is also equal to f of x naught. Okay. So therefore, your a value should be 3, and that is your answer. Okay. So that is, I think, option C. If you just go back, yeah. So it should be C. Okay. Again, this is not that hard of a question compared to the other questions that have been asked in the previous GATE exams, coming from the calculus topic. Okay, there are many advanced concepts in calculus topic, but this question comes under one of the easier difficulty level, provided you remember the definition of continuity for a function at certain given point x naught. Okay, if you had to remember this, then it was a pretty straightforward question. So this was about question number 15. Let's go to question number 16, which is coming from the topic of complex variables. Okay, so every year at least 1 or 2 questions are asked from complex variables. Okay, so this was again one of the medium or easy difficulty level question, but sometimes they ask very tough questions also, which include complex integration, complex differentiation, all those things. Okay, analytic functions, all those concepts. So if you solve previous year questions, you would have seen such questions. But this time around, they have not given you questions from that topics, as at least for aerospace engineering. For other branches, they have. Anyway, that's not the point. So now they are mentioning that this I, which we call iota also. Okay, so this is not your simple I. It's in complex terminologies, it is iota, which is square root of -1. Since it's square root of negative numbers is not defined for real numbers, so that's why we enter in the regime of complex numbers. Okay. And I think there is a typo in this question because it's not a square here, it is actually a cube. Okay, so it is, you need to find the value of 1 plus I cube divided by I minus 1. So maybe there is a typo, please ignore that. You can refer to the official question paper and answer key. So there it is, cube. Okay. So now they have given 4 options and one of them is correct. And I think option A is correct, but we'll see how. Okay. So the given expression is 1 plus I cube divided by I minus 1. Okay. So in this type of questions, usually you have to use some basics, basic concepts of your mathematics. So here you should know what is the expansion of a plus b whole cube. Okay. That is nothing but a cube plus b cube plus 3a square b plus 3ab square. Okay. Sometimes in some problems they modify this expression also. Okay, but no need to do that for this problem. And here you have to put a equal to 1 and b equal to iota. Okay. Some properties of iota you should know, since I is a negative 1, I mean square root of negative 1, the I square value will be minus 1. Okay. And I cube value is nothing but I square into I. So I square is minus 1, so it is minus I. We need these values to calculate the cubic expansion rate. So that's why I'm just giving you here. So if you do that, in this question, this concept is important, basic expansion of cubic a plus b cube formula. In some questions, they expect you to know the factorization of your numerator and denominator. Okay, so you have to multiply by, in some cases, this problem, not this problem, but similar problem could be solved when you multiply numerator and denominator by I plus 1. Then in the denominator, you have I square minus 1, that is nothing but minus 2. So this is not relevant for this problem, but I am just giving you in future if you see other problems, that trick is also many times used. Okay. Nonetheless, come back to this problem. So here you have I minus 1. Okay. So let this denominator remain as it is for the time being. In the numerator, let's expand this. So it will be 1 cube plus I cube plus 3 1 square I plus 3 1 I square. Right? This is the standard expansion of a plus b whole cube. And if you further simplify this, 1 cube is just 1. I cube is minus I. We have just seen here. And then you have plus 3I because 1 square is 1. And since I square is minus 1, the last term is minus 3 divided by I minus 1. The denominator is unchanged. So 1 minus 3 is minus 2. And minus 1 plus 3I. So I mean minus I plus 3I is plus 2I divided by I minus 1. So now you can just take 2 common from the numerator and you end up with I minus 1. Denominator also has I minus 1, so that part gets cancelled. And finally, you end up with the answer which is equal to 2. Okay. So this is, I think, option A. Let me just check. Yeah. Okay. So this is just a simplification of the numerator, and then some terms from the numerator and denominator are getting cancelled. Okay. So this was also a straightforward question from complex variables. As I said, there can be, usually there are 1 or 2 questions. This time they have asked you a straightforward question, but you should prepare this topic very thoroughly. Okay, because these are sure short questions and you should not miss out on those. Okay, if you are preparing for next edition or something like that. Anyway, so answer to this question was option A equal to 2. Okay, so let's move on to the next question. Okay, so this was question number 40 in your paper, and this is also from calculus topic. Maxima minima is the name of the topic for this question. And what they're asking is to find the maximum value of the function f of x, which is given as a multiplication of 3 brackets. Essentially, it is a cubic polynomial. If you expand this, you'll get some x cube plus x square plus some x, those kind of terms. But very important thing is, they are not asking maxima for the whole real line, right? So they are asking you to find the maxima in this domain, which is going from 0 to 3. Okay, and they are asked. This is not a select the correct option type of question. You have to put the data entry, and this is also very important part. Many times students forget these things, and you should know how to round off numbers. It's the basic thing, but I've seen many students don't know. So please keep that in mind. That should be the first thing when you study for GATE. Anyway, so there is a function which is a cubic function, and they have given you one domain, and you need to find the maximum value for this function within these values. Okay. For example, if you just for the sake of simplicity, if you take the real number line, and you should have some idea, okay, because I will give you the way to solve this question. You have to just take the first derivative, then second derivative, and all those things you have to do. That's the classic way to do it, or the conventional way. But many a times you should be smart also in exam, because the time is limited. So one check, if the functions are of easier to plot, what you can do is you can just check the values, and since this is a limited domain question, it is pretty easy to do that. So what I mean by this is, just check the value of function at all these integer points, and you'll get some idea about the nature of this function. Okay. So what I mean by that is, you'll see in this problem it helps. Okay. So now let's first find the function value at x equal to 0. So basically you have to put x equal to 0 in the definition of this f of x. So if you do that, what do you get? Minus 1 into minus 2 into minus 3. Minus 3, right? So that is essentially minus 6. Okay. So, maybe here, let's say this is minus 6 value. So your function is negative when x is equal to 0. Okay, and this is included, right? So you have to consider the domain inside these square brackets. And what is your f of 1? This question, you have to put f equal to 1 in your expression. So that comes out to be 0, right? Because x minus 1 is 0. So the whole function value is 0. So f of 1 is 0. So that means your function is at this point for x equal to 1. And when you put x equal to 2, similarly, f of 2 comes out to be 0 only, right? Because the second bracket is x minus 2. So your function is again going to 0 here. And similarly, f of 3 is also 0. So function is again coming back to 0 at x equal to 3. So now, the only possible course that the function can take, because see, between 0 to 1, it has to come from negative 6 to 0. So it will follow a certain path. I don't know the exact nature of this path, but it will be something like this. And then it has to again come back to 0 at x equal to 2. So it will go like this. And then since it has to again come back to x equal to come back to 0 at x equal to 3, the function has to follow this path. If you are not convinced, you can just do one check also. What you can do is calculate f of 1.5, which is between 1 and 2, right? So if you do that, what do you get? 0.5 into minus 0.5 into minus 1.5, right? So this value is positive, no? This value is greater than 0. So I don't care about the exact value because that's none of my concern. I just wanted to check whether the way I'm thinking the function will behave is correct or not. Okay. Similarly, you can take any value between 2 and 3 and check the nature. It will be negative. Okay. So this is how the function behaves. And after 3 it goes like this. You can just check that also, but not needed since we are supposed to focus on 0 and 3. Okay, so why are we doing this? Because they are asking you to find the maximum value, right? So from this function graph, you can clearly state the maximum value of this function will lie between 1 and 2, right? So maximum value will belong between these points 1 and 2, right? So now you know the answer. I mean the range of the answer. Now just the part that is remaining is to solve this equation and get the exact value. But this type of sanity check, will prepare you for avoiding any mistakes. Okay, because sometimes what happens in GATE exam, you miss some plus minus sign and you do full calculations but get the wrong answer. But in this way, if you know the answer should lie between 1 and 2, you'll not make a mistake, right? Even if you do, you'll go back and correct that. So you'll not lose any marks. So that's why this kind of sanity checks are required. Okay. So let's solve this problem in a conventional way. So you have f of x, x minus 1, x minus 2, x minus 3, and we need to find maximum value of f of x for x belonging between 0 to 3. Okay. So the classic way is to first take the first derivative and equate it to 0 to get the critical points. Okay. So what will be the derivative of this function? You can use the chain rule of function, chain rule of differentiation, because that will be easier. Otherwise, you have to multiply this bracket, you'll get one cubic equation and then you differentiate. That is also one way to do, but it is a time consuming way. So I'll just use the chain rule of multiplication. So what does the chain rule of multiplication means? Let's say if you have two functions, u and v, you take the derivative of first function, keep the second function as it is. And in the next case, you take the derivative of second function, keep the first function as it is. So if you have three functions, it is the same thing only. Let's say you have three functions u, v, w. You have to take derivative of first, other two remain unchanged. Then take the derivative of second, other two remain unchanged. And finally, take the derivative of last, first two remains as it is. Okay. So here u is x minus 1, v is x minus 2, w is x minus 3. Okay. So your f dash of x is nothing but the derivative of x minus 1 is 1. So that is just x minus 2, x minus 3. Similarly, derivative of x minus 2 is also 1. So you will have x minus 1, x minus 3, and the last bracket will give you x minus 1 and x minus 2. Okay. So since your original f of x is cubic function, the derivative will come out to be quadratic function, one order less, right? So now you have to expand this bracket to get the idea about your critical points. And how do you do that? You basically uh, you know uh, this first bracket will be x square minus 5x plus 6. Second term, if you do the multiplication, that will give you x square minus 4x plus 3. And third term will give you x square minus 3x plus 2. Okay. So in the end, you get 3x square minus 5 minus 4 minus 3, so that is minus 12x. And you have 6 plus 3 plus 2, that is 11. Okay. So this is your quadratic polynomial, and you have to equate it to 0. So basically, you need to find the roots of this quadratic polynomial. And you should know, okay, so if you have a polynomial of the nature ax square plus bx plus c equal to 0, your roots are minus b plus minus b square minus 4ac divided by, one second, I am not able to write in that corner. Okay, so it should be minus b plus minus b square minus 4ac divided by 2a. Okay, so this is a standard way to solve the quadratic equations. Okay, so if you do that here to get the values of x where f dash of x goes to 0, so here, if you compare the coefficients, a is 3, b is minus 12, and c is 11, right? So your x values or the critical point values will be minus b, so that is minus of minus 12, so that comes out to be 12, plus minus b square, so that is minus 12 square, minus 4a, a is 3, c is 11, divided by 2a, a is 3. Okay? So these are your critical points. Okay, and you know if you solve this, 144 minus 12 into 11, right? So that is basically uh, root 12. So what do you get is x equal to 12 plus minus root 12 by 6. Okay. So you can divide by 6 or 2 also. So you can further simplify this case. So this will become 2 plus minus, and root 12 is nothing but root of 4 and 2 3. So 2 root 3 by 6, right? So 2 root 3 by 6 will be root 3 by 3, and I can write this as again 2 plus minus 1 by root 3. Correct. So there are two x values where your f dash of x can be goes to 0, or then you need to check whether it's a maxima or minima. For that, we need to do the second derivative. But if you look at these values, so one value is 2 plus 1 by root 3, and another value is 2 minus 1 by root 3, right? So if you go back to the nature of your f of x, so from here you knew that the maximum value is between 1 and 2. So which one of these value lies between 1 and 2? Clearly the second value, right? This value is greater than 2, no? So it cannot be the maximum because we know the nature of your f of x. So you could have directly answered the answer, which was 2 minus 1 by root 3. So 1 by root 3 will be, roughly speaking, let me calculate. Well, root 3 is 1.732. So, 1 second. 1 by root 3 is nothing but, 1 second. Yeah, it is 0.577. Okay. So 2 minus 0.77, it gives you 1.422. Okay, so this value is 1.423. Okay, but they are asking you to round it off till second digit, right? the question, 2 decimal places. So it is just 42. Okay, and this should answer because this is the only value which lies between 1 and 2. But let's say you don't know how to do the plotting of f of x, etc. So in that case, you need to check the second derivative of your function, and it should be negative for maxima. Okay, so what is the second derivative of your f of x? So you have to differentiate this 3x square minus 12x again. So that will be 6x minus 12, right? So your f dash double dash of x is 6x minus 12. Okay, this also gives you, if you put x1 which is greater than 2, this value will be positive, and for x2 value, for x2 which is 1.42, if you check, 1.42 into 6 is nothing but, second, is nothing but 8.52, and if you subtract 12 from this, you get minus 3.8, 3.48, okay, which is less than 0. So therefore, x2 is maxima. Okay, so this is this is your answer, x2 equal to 1.42. But one caution I want to tell you is, in this question we saw that these values at boundaries are not either maxima or minima. So whenever you have finite bounded problem for maxima or minima, I'll just give you one caution note, so that next time, because they have tricked student in previous exams for GATE exam. What they do is, they give you some finite domain between, let's say, A and B, and students, what they do, they follow this conventional method and get some value, but actually the maxima or minima lies on the boundaries. Okay, so the caution note is, always check f of x values or value at domain boundaries before final answer. Okay, I mean, I had told this in our regular classes also. In this case, it is not effective, but in many problems, they trick. Okay, so maxima or minima lies at the boundary only, and the boundary means the 0 and 3 points. Okay, so here we had already checked that f of 0 is minus 6 and f of 3 is 0. Okay, so therefore, f of 1.42, what will be the value? Actually, they are not asking value, so no need to do that. So I'll just skip that part, because they are not asking the maximum value, right? So here you can check, at the boundaries also the value is negative and 0. So therefore, f of x value is maximum at x equal to 1.42. This was your answer. In some questions, they will ask you to find the value of function at 1.42. Nothing to worry. You just have to put 1.42 in the function definition. You will get the answer. So yeah, the answer is 1.42. So this is how you should solve these type of questions. Okay, standard form of question. Just make sure you don't mistake. You don't commit the mistake of not checking at the boundaries. Okay, many times students forget that part. In this question, it did not cost you anything, but in other cases, it is very painful if you miss that part. Anyway, so let's go to the next question, which is question number 41. So this is also again one question in limits topic. Okay. And to be more specific, it is the application of L'Hospital's rule. Okay. And I've seen multiple times this type of questions are asked regularly in the GATE exam. Okay. Not regularly, I mean, by regularly I mean it's like more frequently. Okay, so this is classic question on L'Hospital's rule. Okay, and that applies to this 0 by 0 or infinity by infinity, etc., forms. Okay, there are certain conditions for those, but since here it is 0 by 0, we are not going into details. We do that in our regular classes. Okay, and we had done this in previous batch also. So here the problem is, if you put x equal to 0 in this limit, you get 1 minus cos of 0 divided by 0 square. Cos of 0 is 1, So 1 minus 1 is 0. So this is like a 0 by 0 form. And here you have to use L'Hospital's rule. And what does this rule say? When you have 0 by 0 or infinity by infinity form, you have to differentiate numerator as well as denominator and then check the limit value. If it is a finite value, then you have to stop there. But let's say after first differentiation round, still the value is 0 by 0 or infinity by infinity, then you have to take second derivative of numerator and the denominator, so on and so forth, till the time you get the finite limit. And if you do this infinite times differentiation, still you are not getting finite limit, that means it is a function where limit does not exist for that function at that point. But usually for gate exam, they don't give that kind of problems. Okay. So here you have to use L'Hospital's rule. Okay. So you have to differentiate this. So the limit remains same. So now you have to differentiate 1 minus cos 2x. Okay. So 1 is constant, so that derivative is 0. Minus cos 2x. So derivative of cos is minus sine. So you have minus of minus sine 2x. And then derivative of 2x, which is 2. Okay. This minus sign comes from the definition of function, okay? And the inner minus sign is from the differentiation. And x square differentiation is 2x. Okay, so now if you put the value of 0 in this expression, you are again ending up with 0 by 0 form. So what you have to do is, you have to differentiate further one more time. Okay. Differentiate one more time. Okay. So now you have a function which is, this function is 2 sine 2x, right? And in the denominator you have 2x. Okay. So if you differentiate both numerator and denominator one more time, denominator just becomes 2 because differentiation of 2x is 2. And differentiation of 2 sine 2x. So you need to find differentiation of 2 sine 2x. 2 sine 2x with respect to x. Okay. So the 2 remains as it is. Sine derivative is cos 2x, and 2 comes because of 2x. Okay. So essentially it is 4 cos 2x. So you have 4 cos 2x here. And then, this 2 gets cancelled and you have 2 here. So you have 2 cos 2x. So if you put x equal to 0 now, cos 0 is 1. Okay, so you have the answer 2 into 1. So the limit is 2. Okay. So the correct answer is 2. And they were asking you to answer in integer only. So, sometimes sometimes very rarely they try to trick. If you get some answer in a fraction, they ask you to round it off to the nearest integer. Sometimes they do like that also. So you should know how to round off the numbers. Okay, so that is very important for gate exam. Anyway, so this is your answer for this question. And if you check the previous year gate exam questions for any branch, this L'Hospital's rules question you will find more often. Okay, so this is one of those questions which are easy to guess and easy to solve also. It will not take much time if you know how to do differentiation properly. Okay, so this was about this question on L'Hospital's rule. Now let's go to the next question, which is question number 42. And now this is slightly, I would say, medium to high difficulty question, because you should remember how to do area calculations in polar coordinates. So those kind of things we study in our regular classes. But even if you know that, it is slightly trickier part is there initially, but we'll try to answer. Don't worry. Okay. So the question says the equation of a closed curve in a two-dimensional polar coordinate. So you should know what are two-dimensional polar coordinates. So basically, you represent your point in a polar coordinate in 2 dimension by r theta. R is distance from the origin and theta is the angle from the positive side of x-axis from the origin to the point. Okay. So r theta coordinate system is basically given, and they have given you r as a function of theta. So here your r is function of theta. Okay, and the function is 2 by root pi 1 minus sine theta. You need to find the area enclosed by the curve, and you need to give the answer in integer. Okay, so this much information is given. So if you know the uh, the double integration or multiple integral topic from the calculus syllabus, you know that in polar coordinates, so if you want to find the area, you have to integrate first with respect to, you can do with respect to r first or theta, doesn't matter, as long as you put the proper limits. And then you have to, integrate r dr d theta. Okay. In Cartesian coordinates, in xy coordinates, is also called as Cartesian coordinates. The area integral is straightforward because you just do x and y integration and you just do the dx by dy integration. But when you go from Cartesian to polar coordinate system, this rdr concept, component comes. It's not only dr d theta, okay? So you should remember that part. And we have seen this because when you transform the coordinate system, essentially you do the Jacobian transformation. And we had seen in the regular classes how to do the Jacobian calculations for various transformations, etc. Okay. So sometimes they can ask you, instead of polar coordinate system, spherical coordinate system also. So there also you are supposed to know there will be r square sine theta, then dr d theta and d phi. So there you have r, theta and phi. So azimuthal angle and all those things are there in spherical coordinates. But in this question, they are just asking for polar coordinates. Okay. So now here the trick or the the important part is, here they have not give you r as a separate entity, right? They have not given you r limits, etc. They have given you r as a function of theta only. Okay, so what you can do here is you can just do the integration, inner integral with respect to r. This part remains as it is, d theta. So integration of r dr are going from certain values. We don't have exact limits of r, that's why I'm just putting this as some limits of r. So that will come out to be r square by 2, right? So this is an indefinite integral basically, but we don't take constant because finally we end up with some finite answer, right? So basically, if you want to know, this should be like this. Okay. So that is the main question, main trick that you should figure out for these type of questions. Okay. So therefore, you just have to put r square by 2 here. And now since r is function of theta, your area is nothing but the theta value. Since you have see the nature of your r function. Your r function is 2 by root pi into 1 minus sine theta, right? So this sine function is a periodic function. Okay. So basically, theta varies between 0 to 2 pi. Okay, so you have to take those limits, theta going from 0 to 2 pi, and r square by 2 d theta. Okay, so 1 by 2 r square d theta you have to do. Now everything is in front of you. Okay, 1 by 2 comes out of the bracket or integral sign, and r square will be 4 by pi 1 minus sine theta whole square d theta. 4 by pi also is a constant, comes out, so it becomes 2 by pi outside. You have 0 to pi, 0 to 2 pi, sorry. And then you have to integrate this square. Okay, so 1 minus sine theta square, you can do the expansion. So it will be 1 plus sine square theta minus 2 sine theta, right, d theta. So now you can do the piecewise integration also. So that is also fine. So now you have to integrate 0 to 2 pi 1 into d theta, that is first term, plus 0 to 2 pi sine square theta d theta minus 2 sine theta d theta, 0 to 2 pi. And we know this condition that if function is odd, then 0 to 2 pi, basically, sine theta, if you remember the nature of sine theta, it is like this, going from 0 to 2 pi, right? So essentially, this integration cancels out. Okay, so you don't need to find the last integral because this will come out to be 0. You can do it because integration of sine is minus cos, so that will be cos 2 pi minus cos 0. Cos 2 pi is 1, cos 0 is also 1. So that last integral is 0, but I know the nature of sine function, so I can directly use the property of that and save my time and not do the last integration. Okay. First integration is easier to do, right? So it is just theta going from 0 to 2 pi. So that comes out to be just 2 pi. So first integration is just 2 pi. And now this one, sine square theta. Okay. So you should write sine square theta as a function of cos, right? So we know that sine square theta is 1 minus cos 2 theta by 2, right? So you have to use that formula for the second integral, which is going from 0 to 2 pi, 1 minus cos 2 theta by 2 d theta. Okay. So, you can multiply this 2 pi with 2 by pi, so that 4 remains here. And then you have 2 by pi. And then, this 0 to 2 pi. 1 by 2 you can take it out, so that will cancel out this 2. So it will become 1 by pi here. Okay. And then you have 1 minus cos 2 theta integration. So 1 minus cos 2 theta d theta. Right. So again, you can use piecewise integration. So that is again 0 to 2 pi, 1 into d theta minus 0 to 2 pi cos 2 theta d theta. Okay. So bracket complete. Here also, see, integration of cos is sine. So this value, the first integral value is nothing but 2 pi. Second integral value, integration of cos 2 theta will be sine 2 theta by 2, right? And any sine value going between 0 to 2 pi is 0 only, right? So what I mean by that is sine 2 theta by 2, right? And the limits of integration are from 0 to 2 pi. And we know sine n pi is 0 for n going to positive integers, n going from 0 to 1 and so on and so forth. Okay. So sine 4 pi is 0 and sine 0 is 0. So this whole bracket is 0 only. Okay. So finally, what answer do you get? 4 plus 1 by pi into 2 pi. 2 pi comes from this term. So that is 4 plus 2 and 6. Finally, the answer is 6. Okay. So if you just check, yeah, the answer is 6. So the only thing that you should, to solve this question, the only thing that you need to improvise was this part. Okay. If you had connected this with the concept of multiple integrals that we have, you could have solved this question within a reasonable time. Okay, so I would. That's why I'm saying this is one of those questions which is medium to hard difficulty. Okay, but nonetheless it was solvable, not that difficult. Okay, so that's why this is the procedure to solve such questions, and the answer comes out to be 6. And they're asking you to give integer answer, so 6 is the correct answer. No need to round off anything. Okay, so this was question number 42. Now let's go to the next question, which is, I think, question number 43. And this is again from our differential equation topic, more specifically ordinary differential equations, or we call them as ODEs. Okay. So, This is also very frequently asked question. Okay, so this is integrating factor type of ODE. Okay, I mean there is one method to solve ODE which is called as integrating factor method. So maybe I should write that way. Integrating factor method for ODE. Okay, so this type of questions are repeated more frequently. I'm telling you, if you check the previous year questions from ODE topic, this type of integrating factor method is widely repeated. Okay, so what is this method? We had discussed this extensively in our previous classes. Okay, so here you have the uh, differential equation or the ODE, ordinary differential equation, of the form dy by dx plus some function of x, which is p of x, into y will be equal to some function of q of x. Okay, so if your ODE is of if you can write your ODE in this form, you can solve this using this integrating factor method. Okay, and here if you do slight modifications to your given ODE format or the structure of your ODE, you can write this, right? So basically multiply by 2 on both the sides. So you will get 2 by x into y equal to 2. So if you compare coefficients of these two equations, you can say for a given question, t of x is nothing but 2 by x and q of x is nothing but 2, right? If you had guessed or identified this one, it would have been easier to solve. And apart from that, they have given you some initial values. Okay, so they have given you that at x equal to 1, y is 2 by 3. So what that means is y of 1 is 2 by 3, and you need to find at x equal to 3 what is the value of y. So basically you need to find y of 3, and it's a data entry question and you need to round it off to the nearest integer. Okay, so you can't put it as point something something, you have to round it off to the nearest integer. Okay, so this was all the information given, and this is a standard integrating factor method question. Okay, so there is a standard procedure to solve this. Okay, so if you have dy by dx equal to p of x into y equal to q of x, then integrating factor, we use if as the abbreviation for this, is given as e to the power exponential of integration of q of x dx. Okay, so sorry, not qp, apologies, it is a p of x dx. Okay, so here p of x is 2 by x, so you need to find e to the power 2 by x dx. Okay, so 2 is a constant, it comes out of the integral sign. So essentially you need to find the integration of this one, 1 by x dx, and we all know it is natural log of x. Okay, I'm not writing that plus c because eventually we consider the c in the final form. So constant, arbitrary constant, I'm not writing here. Okay, but here there is a 2 which is multiplied outside, right? So therefore it will be 2 into ln x, which is nothing but ln of x square, property of logs. Okay, so therefore it is e power ln of x square, and if you know the property of exponential functions, this is nothing but just x square. Okay, so this is your integrating factor, and the solution to this equation, let's say 1, solution to equation 1 is given as y into integrating factor equal to integration of q of x into integrating factor uh, with respect to x, so therefore dx will be there, plus some arbitrary constant of integration c. Okay, so this is standard method, so there is a standard formulation for solution. But if you don't remember this solution statement, then also you can solve it. What you need to do is you need to multiply by this integrating factor to both sides of this given equation number 1, and then the LHS becomes a uh, this thing, one simple differentiation, chain rule differentiation. Maybe I'll do it on the next slide, but let's solve this here with our conventional method. So y into x square, because integrating factor is x square. Now we have the q of x was 2 in this question, so it is 2 into x square dx plus c, right? So this is nothing but x square y equal to x square integration is x cube by 3, so you have 2 by 3 x cube plus c, right? I can divide both sides by x square, right? So then what I get? Y equal to 2 by 3x plus c by x square, right? Now to find the constant of integration, we need to use the given condition, which is initial condition, that is at x equal to 1 y is 2 by 3. Okay? So at x equal to 1 y is 2 by 3. So if you plug this information in our solution equation, so 2 by 3 is equal to 2 by 3 into 1 plus c by 1 square. So that gives you c equal to 0, right? Then only the equation will be satisfied. And if c is 0, then y is nothing but just 2 by 3x. And they want to finally answer what is the value of y at x equal to 3. Okay? So therefore, y at x equal to 3 will be nothing but 2 by 3 into 2, 2 by 3 into 3, because x is 3, which is equal to 2. Okay, so this is your final answer. Okay, let me just cross check. Yeah, so the answer is 2, because you need to put it as an integer. And as I said, there is another method. So since if you find x square, and if you don't remember this final form of the expression, which can happen in exam, there is a simple form. Simple way to do this is multiply by the integrating factor, which is x square in this case, to both sides of equation 1. So whatever your given ODE is there, you have to multiply both sides of that equation. So you will have x square dy by dx plus p of x is 2 by x, right? So x square into 2 by x into y equal to 2 into x square. Okay, and that is nothing but x square dy by dx plus 2xy equal to 2x square, right? And if you pay attention, this can be written as d by dx of x square y equal to 2x square. Okay, and then you integrate on the both sides and you'll get the same answer. Okay, because this integration will give you x square y, and this will give you 2x cubed by 3 plus c. And this is what we got, right? This is what we got by using our standard method also. Okay, so there are multiple ways to do this. I'm giving you these because this integrating factor method is very important and it is asked many times. So the answer is 2, and there are a couple of ways to solve this, which are as shown on this slides. Okay, so with this, let's go to the next question. I think a couple of more questions are pending, and we'll just finish it off. Yeah. Okay. So I would say this previous question, integrating factor method, medium level of difficulty, because you need to remember some things, and you need to first identify that it is an integrating factor method type of ODE. If you do that, it is a straightforward question. Okay, so let's go to the next one, where this is question number 44, and they have mentioned that an approximate solution of equation x cube minus 17 equal to 0 is to be obtained using Newton-Raphson method. Okay, so this is the question from numerical methods topic, and they are asking you to find this approximate solution using NR method or Newton-Raphson method, we call it. Okay. So what is the Newton-Raphson method? So it is also, we had solved many problems on this. Okay, so let me just check once. Yeah, so you should first remember what is Newton-Raphson method, And then additional information is that you need initial guess for all the numerical methods. For this method also you need initial guess, and that is given as x not equal to 2. And they want the value of your solution, which is, x value keeps on updating because these are iterative methods at the end of first iteration. Okay, and you need to round it off by up to 2 decimal places. Okay, so they can, in this question they have asked you only up to first iteration. There can be a question where they will ask you 2 iterations, 3 iterations, all those things. Okay, so you have to do the calculations iteratively. Okay, so to solve these type of questions, the first thing that you should do is, you need to write the given equation, write given equation as f of x equal to 0 form. Okay, so here they have given you directly in the equal to 0 form only, but in some problems they give you some tedious kind of equations. So you have to take all the variables and corresponding constants, etc. on LHS, and RHS should be 0. Okay, so here f of x that you have is nothing but x cube minus 17, right? So this is the first thing that you should do, and then you should know the standard Newton-Raphson method. Okay, so NR method we call it using the acronym. Okay, so here the value of your solution starting from your initial guess x naught is given by this iterative correlation, which is f of x divided by f dash of x naught. F dash is the first derivative of your f of x. Okay, so since your f of x is x cube minus 17, your f dash of x will be just 3x square, right? Because 17 is the constant, its derivative is 0. Okay, so this is your first iteration. If they ask you to do second iteration, then x2 will be x1 minus f of x1 divided by f dash of x1. Okay, so like that the index will keep on updating. But since here they are only asking x1, you need not to do the calculations multiple times. What you need to do is to find these values. So they have given x0 as 2 in the question. So what is your f of x0? That will be 2 cube minus 17. So 8 minus 17, that is minus 9. And what is your f dash of x0? That is 3 into x square. So 3 into 2 square, 4 into 3, 12. Okay. So therefore your x1 is 2 minus f of x0 is minus 9 divided by 12. Okay. So that is essentially 2 plus 3 by 4. So 3 by 4 is 0.75, so it will be 2.75. Okay, and they were asking you to round it off to 2 decimal places. So 2.75 is the final answer. Okay, that is the correct answer also in the given in your answer sheet, answer key. Okay, so this was the standard NR method question, Newton-Raphson method question. Okay, so they have asked Newton-Raphson this time. They may ask other methods also. So we have discussed multiple methods in numerical methods topic. So any one of them they can ask, and they can ask you to do multiple iterations also. So you should be able to do all those things. Okay, and then let's finish the last question, which is question number 45. And I would say this was one of the trickiest question from maths topic for this paper. Okay, because the remaining ones, only that r square by 2 d theta, that one was the difficult one, and this one is also difficult one. This is not difficult as such, but the thing is, it's a trickier question because I will explain in time, but these 2 questions only were difficult. Other questions were quite straightforward, and I expect my students to solve those things. Okay. So now in this question, they have given that I cap and j cap denote unit vectors in xy directions respectively. And very important, this is the main key point. If you pay attention to this keyword, you will be careful in this question. Otherwise, you will make a pretty straightforward mistake. The outward flux of the 2-dimensional vector field v bar, which is xi cap plus yj cap, over the unit circle centered at the origin is, and it is also data entry, and two decimal places round off your to do. Okay, so basically what they are asking you to find is, if you consider a unit circle centered at origin, unit means radius equal to 1. Okay, so let's say this is your origin, and let's say this is your xy field, and this is your unit radius. Okay, and you have this vector field which is x plus y j. Okay, so if you can imagine, this field is, it is like this, because at any point if you take x and y values, so in first quadrant they will be positive, right? So the slope will also be positive. Similarly, on y axis, since y is greater than 0 here, v field will be uh, in the positive y direction. Similarly, like this. Okay, so this is your vector field. Okay, so this is a outward spreading vector field, so it is going through this unit circle also. Okay, like in this direction. And now they want you to find the outward flux. Okay, so they have given you this unit circle, right? So you need to find how much outward flux is going from this boundary, closed boundary. That is the question. Okay, and why I told you in the initially that many students would have make mistakes in this is because when you see this type of question formulation, uh, you know usually students directly solve it by using Green's theorem. Okay, so what they do is basically need to find uh, this one, right? uh, Along the closed boundary, and let's say some surface area, elemental surface area, and they use this pdx plus qdy integration, right? So you must have seen these kind of problems using Green's theorem, and solve using Green's theorem. Okay, and in Green's theorem, what we basically do is you convert the closed line integrals into surface integrals. Okay, and then you take the curl of your integrand, and then you take the area integration, right? But the thing is, here they have not asked you this. Okay, so if I am assuming most of the students would have done this, because these are the typical questions asked in the similar format. But the only distinguishing factor was they were asking outward flux. Okay, so they were not asking the line integral over this contour. Okay, they were interested in the flux. And one note that I would like to give you is, whenever anybody is talking about the flux over certain boundary or certain surface area, the divergence has to come into picture, because divergence of any vector represents its volume expansion or volume contraction, right? I mean, volume is a loose term, but for any vector field, if it is expanding or compressing, that is represented by its divergence. Okay, so in this case, you know, so what I'm trying to tell you is, if your v bar is your vector field, and if you are doing this integral over the closed contour C is your circle of unit radius 1. Okay, so there are two ways to do this. You can use Green's theorem. You know, using Green's theorem, basically Green's theorem, what it does is, in simple terms, uh, you should know. I mean, this is, I think, the first time they have asked this type of question. So, uh, this application of this thing, to say flux for a 2D. See, whenever they used to ask flux in the previous year gate exam questions, they used to give you a 2D surface, and then they used to ask the flux. So in that case, you have to use Gauss divergence theorem and get the flux, right? So you need to do volume integral of divergence of vector field, and then you get the answer. But this is the classic problem of 2D Gauss divergence theorem. Okay. So anyway, I'll just give you, if you had used the Green's theorem, it integrates basically, this Green's theorem integrates tangential part of the vector field. Tangential part of the vector field. So here the vector field is v bar, right? So when you do this Green's theorem calculations, you are not calculating flux. You are calculating the tangential part of your uh, vector field along the contour C. Okay, but here they are asking you to find the normal part, which is called as flux. Okay, so for that you need to use uh, this thing, which is called as sometimes they call this as flux form of Green's theorem, or they also call this as 2D divergence theorem. Okay, so these are different name for same thing. And what it does is it essentially tells you that when you do this line contour integral, you have to equate it to a surface integral where you take the divergence of your vector field and do the surface integral. Okay, so this is the trick. Most of the students would have done this, and if you do this way, you would get the answer equal to 0, and that is expected because this vector field v bar is always normal to this circle, right? Because everywhere it is expanding along the unit circle. So if you follow Green's theorem that we usually follow, the answer that you would get is 0, but the answer is not 0 here. Okay, so that is where the most of the students would have made mistake. Okay, so nonetheless we'll solve this in a correct way. So we need the outward flux, right? In the question what they're asking is outward flux. So for that you need to use the flux form of Green's theorem, and the flux form of Green's theorem, or you can call this as 2D divergence theorem also. Some books you'll see. If you have vector field, let's say in this form, let's say some f of xy I cap plus g of xy j cap. Okay, so some general flux I'm writing. Then the closed contour integration of these vector field along the normal of the unit circle at each and individual point along the closed contour C is given as the divergence of V bar into dA. Okay, so here the divergence of V bar will be nothing but del F by del X plus del G by del Y into dA. Okay, and in 2D you can write dA as dx dy also, so that is also possible. So coming back to the given question, V bar is X into I cap plus Y into J cap, right? So what will be the divergence of V bar? That will be d by dx of x plus d by dy of y, because f and g are x and y here. So that is 1 plus 1 equal to 2. Okay, so therefore the outward flux or total outward flux, sometimes they call this as net outward flux also, which is given by this line integral of vector field and the unit normal at each and every individual point over the closed contour, which is a circle here. That comes out to be 2 into dA over the area of integration. So here it is circle, right? So 2 comes out of the bracket, and this is just 2 into dA. Okay, so since our area of integration or the boundary that we are studying is a unit circle, right? So r is equal to 1, so the area is pi r square, right? So area is just 1 because r is 1. Okay, so the outward flux or total outward flux comes out to be 2 into this elemental area, right? So that is nothing but pi. R square is 1 square. So basically the answer is 2 pi. So pi is 3.14, right? So uh, basically they wanted you to round it off to 2 decimal places, right? So in that case, pi is 3.14 and 2 pi will be 6.28. Okay, and this is your answer. Okay, and let me just check. Yeah, 6.28 is the correct answer. Okay, so this is the, I would say this was the most difficult question, not because of the nature of the question. It's just that they have tricked in the language of the question. Okay, so most of the students who would have attempted this question would have gone by Green's theorem in a conventional sense, but that will give you the answer 0. But that's not the answer because they are not asking you to find the tangential component. Okay? They were interested in the flux, which is normal out. Flux is normal component. Okay? So normal component they had asked. Okay. So you have to use the this form of Green's theorem, flux form of Green's theorem or 2D divergence theorem. Okay. So with that, I think all the questions are over, and we had discussed most of these questions in our regular batches. So if you are interested, you can consider joining them for consequent exams. Okay. So with that, Dinesh sir, I am done. So shall I close the class or session?
Yeah, please go to last slide and then we'll close. Thank you.
I'll share the notes, sir. 1 second, or not required.
Yeah, it's not that much required. Yeah, yeah, please share. Yeah, yeah, please share. Yeah, thank you.
Okay, sir. 1 second.